For Chapter 4, we are very interested in several different kinds of concentration units because Chapter 4 is all about solutions. Now, solution, we're always talking about the solute dissolved in the solvent. Okay, and so our little picture here is just a cute thing about a mole in a solution, so that might be a molarity, how many moles per liter. But we will be looking at, we've seen molarity before. Another one is molality, mole fraction, and weight percent. So those 4 concentration units are ones that show up in our AP curriculum. The other thing we need to be able to do is if you're given any one kind of a unit, we should be able to go back and transfer that into other kind of units. And we're going to have to do that by sort of dissecting the number that we're given into a couple other numbers that we can turn into the other concentration units. Now, the different definitions we have. Molarity, we've seen this a long time ago. Molarity is the moles of solute divided by liters of solution. Now notice not only, what are we talking about, moles or liters, but are we talking about the solute, or are we talking about the solution, or the solution, the solvent, or the solution, being the solvent and the solute mixed together. So molarity is moles of solute over liters of solution. Okay, molality, I think I said that, molarity. Molality is moles of solute, same thing, but this time it's kilograms of solvent. Kilograms of solvent. And if you do calculations, you're going to find out, let's say that it had a liter of water, that it would be pretty much a kilogram. So for dilute solutions, molarity and molality come out pretty close. As they get more concentrated, they're quite a bit different. Mole fraction is the number of moles of solute over, we could say, the moles of solution, although it's a little bit more useful to think of it as moles of solute plus moles of solvent added together. So moles of solute over the total number of moles in that solution. And finally, weight percent, similar. Grams of solute over the total number of grams, which would be grams of solute plus the grams of solvent. Now, if we have a problem, then if it just says, what is the concentration, and given some information, then you can just use the definition. But a lot of times it'll say something like, you have a 6% solution by weight, and we're going to take that information and kind of dissect it into all the information that's in this chart. And we don't usually use those 2 boxes. But you might talk about the mass of a solution. Okay, and I talk about the mass of the solute, mass of the solvent. Add those together to get the mass of the solution. Moles of solute, moles of solvent, and then add those together to get the moles of the solution. And sometimes we use the density, and the density a lot of times is very helpful to get the volume of the solution. And we'll see an example of this in a minute. I picked a couple of problems, 3 problems from the study questions. And you have the answers to the study questions in your study guidebook, or you can go back onto our website and look for things, look for the answers. Now, it says here a solution of salt. Okay, now this says molar mass is 90 grams per grams per mole. So that means this salt we're talking about is not normal table salt, because table salt is sodium plus chlorine, and if you add those 2 things together, you would get about 58.45 grams per mole. So this is some other salt. So, but anyway, salt. If you make some salt water, you'll find out that it has a greater density. In this case, we're saying it's 1.29 grams per milliliter, whereas normal water, pure water, is about 1 gram per milliliter. So this is a cute picture I found, where they're floating a golf ball in some fresh water, salt water, and they put some blue food coloring in so you can see the difference. And the density of the salt water is greater than the density of the golf ball, and the density of the tap water is less than the density of the golf ball. So the golf ball kind of sits more or less between the 2 layers. Now that's just a nice illustration. But here's the situation. We're saying that the concentration of this salt is 35% by mass. Now, just when they say that, that actually gives us usually two numbers that we can turn into a lot of other numbers. So let's dissect this concentration. So if we say 35%, so we say 35% means 35 grams of our salt, and that also means that we have 100 grams total mass. Now that total mass must be our salt plus our water. So if we subtract those two, we get 65 grams. So we know that must be 65 grams of water. So here we have several useful numbers already. Okay, 35 grams of salt, that's our solute. We have 65 grams of water, that's our solvent. And 100 grams total. Our density here is going to be helpful because we can say, well, if we have 100 grams, if the whole solution weighs 100 grams, we know it's 1.29 grams per milliliter. And we can change that in milliliters. We know that 1,000 milliliters is 1 liter. So we can see that by doing our calculation, we can calculate the liters of the solution. Now, if we do that calculation, we find out we get 100 divided by 1.29 is about 77.52. So this would be 0.07752 liters, which would be a useful number. Now we have the grams of salt. We can change that grams of salt, knowing that there are 90 grams per mole. So we can calculate the moles of our salt. And here we have water. And we know that water is 18.02 grams per 1 mole, and that's just adding together the molar mass of oxygen and 2 hydrogens. And we can calculate the moles of water. So we're going to go back, and we're going to say that what we've already know, that we can take we have the mass of our solute, that's our salt. We've also figured out the mass of the solvent, because we know we added up and that we got 100 grams of our solution. Because of molar mass, we could find the moles of our salt. We found the moles of our water, and we can add those two moles together to get this one. And then using density, we were actually able to calculate that guy as well. So let's go back and clean this up a little bit. So if we wanted to calculate the molarity of a solution, molarity is moles of our solute over the liters of our solution. So we just use those two numbers, divide them, we could get molarity. What about if we want to do molality? Well, molality is moles of our solute over kilograms of solvent. So here we know how many grams of solvent, we could calculate kilograms of that and divide those two. If we wanted to do something, let's say like the mole fraction, well, mole fraction would be moles of our solute over the total number of moles, because we calculated the moles of our solvent and added together. So if we get moles of solute over the total number of moles, okay, then we could get mole fraction. And finally, if we wanted to do something like, let's say the percent by mass, we could do the mass of the solute, and we could get the mass of the solution, okay, times 100. So using 2 boxes at a time, then we can calculate any of those any of our 4 different concentration units. So again, taking a number like this, we can dissect it into at least 2 numbers, and maybe a little subtraction, we get 3 numbers. We can calculate these grams into moles. We can use density to calculate volume, and then put all these back together to get any kind of concentration we want. Now, another problem, problem 2. This is talking about ethylene glycol. Now, ethylene glycol may be something you haven't heard about. However, you really kind of ought to know a little bit about it. It's an important chemical, and it is an alcohol, because we've seen alcohols have OHs, and this one is actually a double alcohol. So it just has a common name, ethylene glycol. Ethylene glycol is used in antifreeze, keeps the water in your radiator, since a solution boils at a higher temperature and freezes at a lower temperature, it keeps the water a liquid in your cooling system in your car, which is pretty important. Now, this we're talking about taking ethylene glycol and adding it to ethanol. Now, ethanol would look exactly the same as this molecule, only it wouldn't have one of these oxygens right there. It would just be CH3CH2OH. So these two, you can expect those to mix pretty well. So we're saying let's take ethylene glycol, 150 grams, and we're going to mix it to ethanol, which is 250 grams. Now you can see already that we have grams and grams, two masses, and we know what these chemicals are. So we could go ahead and change that into moles, and we could change this guy into moles. So we would have grams of ethanol, we'd have grams of ethylene glycol, we have moles of ethanol, and we have moles of ethylene glycol. Now, the question here is calculate the mass percent of ethylene glycol in the solution. So all we need to do is take the mass over the total mass times 100. So there's part A, we could do that. Part B, calculate the molality. Well, the molality would be the moles over the kilograms of solvent. So let's change colors here. Okay, so we'd have moles of our solute. Here we have grams of our solvent, and we could change that to kilograms, 0.25 kilograms, and we could figure out part B. Part C, calculate the mole fraction. Well, if we add these two moles, we can get the moles total in our solution. So if we take the moles of our solute divided by the total number of moles, that would be mole fraction. So again, just by a couple of simple calculations, going from grams to moles, and then we could put together all three of these different concentrations from the given value. Last one here, a little bit of talking about concentrated sulfuric acid. Now, concentrated sulfuric acid, H2SO4, is very dangerous. It'll burn your skin very nicely. But what happens here is that it actually eats through paper towels. So, if it drips on a paper towel, you can just see that it eats away. It's a dehydrating agent, pulls out the waters and leaves the carbon behind, and it will do the same thing to your skin. So we'd be very careful with concentrated sulfuric acid. But as a problem, we have no problems here at all. So let's look at this, and we say we have something that's 5% by mass, and reading carefully, we're saying that sulfuric acid has very little water in it when it's made. So the amount of water in it is 5% by mass. And we also have the density. So let's take this and dissect this number. So we're saying we have 5 grams of water in every 100 grams of our acid solution, of our concentrated sulfuric acid. Now, we can see again that we're talking 95 grams, and what is that? That is our that's our acid, H2SO4, and I was going to call that our solute, and it's a little confusing here because we're really saying we have H2SO4 dissolved in water, but there's lots more H2SO4 than there is water. So as long as we keep track of what chemical we're talking about, we can call it a solute or a solvent. We don't care. But we do have 5 grams of water, we do have 95 grams of sulfuric acid, and we have 100 grams of solution total. Now, using our density, let's change our 100 grams into milliliters. And we could take that and can further go from milliliters into liters. So we could get the volume of our acid solution. Now we want to do the molarity. Okay, and we know that molarity is moles of our solute, in this case it's H2SO4, over liters of solution. So the answer we would get for this problem here is going to be our liters. And if we have 95 grams of H2SO4, we know what the chemical is, then we can calculate sulfur plus 4 oxygens and 2 hydrogens. It's something like 98.1 grams for 1 mole. And we can get moles, And that's going to be this part of our calculation. So we can use our 95 grams to get moles. We can use our density to get the volume of the solution, divide those two, and we get the molarity of the acid. So the idea is, by taking one little number that is given in each problem, that we can dissect that number usually into 2 numbers, sometimes into 3 numbers, and we can start using molar masses to change grams to moles, or we can use density. Okay, a lot of times we need density if you see molarity in order to get the volume of our solutions and take the information we're given about one concentration and turn it into lots of other concentrations. And that's what we're doing.